No, no, it's not sure. Is this sold at the office? Yeah. No, I bought it. I got it last summer. I think it's worth it.
I went into many angles of the developing of the omni-medium transport and experiences that I had. I did speak to you about the problem of the men who worked for me not daring to finish the car because they meant they were all going to go off and the family would meet again. The depression was so vivid in their feelings. And I kept on really through the doing the car number 3. And when in doing car number 3, that was the one that really to wipe out all the stigma. My mother died, and she left me some inheritance, and I had to spend all of that on car number 3. And I came pretty close to the ends of my funds, and in order to be able to carry on, I was selling shares in General Electric, whatever it might be, Standard Oil, and there were my brothers and sisters. There was bank, which was a co-administrator of the will, and when I needed some money, they couldn't do it right away, and I learned a great deal incidentally about banks really delaying the sales, where the banks get together, and when they sell it, they all know when they're selling some kind of stock, so there really was quite a lot of manipulation involved here. They had orders from numbers of trust funds, quite different from just order of an individual in the stockbroker's house where he has somebody buying something, and it happens just like that. But there are enormous numbers of banks handling enormous numbers of trust funds, so that they can really get together, and it means quite a lot suddenly going to sell General Electric in a big way, or selling Standard Oil, whatever it may be. Anyway, they were not very prompt. When I needed money, it would take me quite a long time before that money would arrive, and the depression was so bad, and I owed money to 2 or 3 people in Bridgeport, lumber firm and others, and the sheriff came around to see me one day, and he said that these people here are getting worried about your accounts in town, and you're the only one that has any money in town anyway, and it looks like it's running out. And I then showed him, went over the book so he could see that I actually had some money and that I had ordered sale, and that I was going to be able to meet all my bills. And he said, you really are in trouble here because your workmen, I had been trying to lay off my workmen, and when I did this, suddenly the windows would be broken, and I had a building full of, I'd bought the machinery. I bought it really very, very cheap because the Bridgeport is a very mechanical town, and so it's easy. I get lathes, I got beautiful things, but nobody's using those things anymore, so I was able to buy them. So I had really quite a beautiful shop set up there. And when I tried to close it up, things would go wrong all the time. I didn't own the building. It belonged to the Bridgeport banks, and they just rented it to me. So it was a rented building and full of my tools. And I didn't want to spend the money to move the tools. In fact, I didn't know where they should go. I've been glad to have sold the tools, but anyway, there were no customers to buy it. There's still very much depth of depression. So Shire said, your man, I've talked to them, are just not going to allow you to close your place up. They're really so afraid about their job. He said, there's only one way you could really get out of here and not go bankrupt, because I can see you are going to use up your funds and then try to you're going to be forced to keep on going to spending money and not producing anything, not using it. So he said, if you will let me as sheriff out, I will make sheriff sale. I'll sell your auction machinery for you and close you up and do so in the minimum amount. He said you just wouldn't be able to do that, and so I let him do it. I ended up with owing nobody any money, and I'd learned a great many lessons, and that was that. made me, however, in thinking about strategy of the little individual taking initiatives, I made up my mind that thereafter I've never owned tools. I had really had quite a lot of shops. Once you think about the experience I had in just in producing the 240 houses in the early 20s, 1922, I got 5 factories going, and I invented my own machinery for making those fibrous blocks. It was interesting that the day after I talked about the fibrous blocks, somebody called my attention to the fact there's a room outside here in the studio that is lined with the material that I produce, in which the company, as I finished it up, sold it out to Celotex company for what they call Soundex. And it's still really the best sound absorption material you can get. Now, I had then invented machinery for mixing this. It was a machinery, I had to have something where I did not take a heavy cementing material and just clot it together with this fibers. And when you had found that the wood excelsior was best, I tried all kinds of things. Seaweed from the Sargasso Sea, there are all kinds of dried grass and things, but nothing really worked quite so well as actually shredded wood, deliberately shredded wood, and something you could manufacture quite rapidly too. So the idea was then to make a block that was really lightweight, looked like a felt hat. And so what I had to develop was a means of, I learned how to do it by just taking pitchfork and putting this wet cement on it, so it looked like more or less milk and cream on there, and taking pitchforks and with a number of guys and continually just pulling it through the way you pull spaghetti out of a bunch and keep spearing and throwing it up in the air, and gradually you spread the material over all the fibers. I had to invent a machine that would spread this liquid very thinly, but enough, but also to saturate it, to beat it, so that I developed then a great tumbling drum. And this is before we have the cement tumblers that you see going along the highway. In fact, they came out of this particular invention, where I then had developed a way of having a gear wheel on the outside of my drum and driving it round, and driving around fast enough so that this material tumbled. It went like a wave on the beach, cresting, throwing it over, and I moved it at a speed where it would crest over, and then I had a shaft going down through the center of it with a great steel tongs on it, very much like the pitchfork, but this being the shaft. So the head of one was over the end of the other, but base of the other, so never the fibers could never get in onto the shaft and wind up on the shaft. And then I was able then to introduce the unbaled excelsior and the liquid at the front end, and this whole thing was slanted, and they start cresting over and landing on those forks and being thrown into enormous. Then I had to have a scraper at the top, because I found that the liquid tended to stick on the thing, so the scrapings were always dropping down onto the tongs and below. So by the time it came out the other end, it was incredibly beautifully softened up and absolutely covered with it, but no masking at all. And then from there on, I had a conveyor belt, and I used what was used for silos, filling silos. I had a tray, then a big blower, and I blew this down into molds. And my molds were full of holes. They were like the lightning holes. I made 6 blocks at a time, and two big forms looked like shells. They looked like the shells you use for firing from a big cannon. There are 2 of these for the 4-inch holes coming to a streamlined point, and they sat inside in a jig inside of a. We took a perforated sheet metal made into a cage, and it fitted down into a jig, and so just exactly 16 inches long and 8 inches wide, and the holes enriched, and this fiber stuff was just blew in around the streamlined cores and filled it up, and then we lifted that whole thing off, and it went on. So it would set up chemically in a few hours, and then when we finished that, we had a saw and cut them into separate 6 separate blocks. And when I had to develop my own machinery, it was a very fascinating matter, and I developed till we got to the right material, which was this magnesium oxychloride cement. We tried all other kinds of cements, some cheaper cements and so forth, and I had to have kilns. So I learned a great deal about oil burning kilns and built my own kilns and a little railroad track in my shops and things like that. It was a very fascinating, basic experience of a young man getting into production engineering and reducing to practice various inventions. One of the early patents I had was on this fibrous thing. Found the only other fibrous handling like this was in making felt hats. It's quite a game, and so I went up to Waterbury and studied the hat-making industry and so forth, which was quite fascinating. So there they also took the hairs of the hare, the rabbit and so forth, and they got them into the air, and then they sucked them in all uniformly. They got saturated with the air that's flying around, and then pulled that whole thing at once. And they just pulled it down, they felt it down so beautifully. This is all part of what I'm saying now. I'm saying to you because of the world game idea, and I found that how little human beings really understood about my world gaming. Quite easy to understand the geoscope, looking at the Earth all at once. It's quite easy to think about getting inventorying of the world resources wherever they occur. It's easy to think about how you get the data of where all the people are. And so it isn't just a matter of playing a world game with moving resources around to people at all, and just things like a business or distributing of materials, because the materials mean nothing. As I said, you have to take them from halfway around the world. You have to know your engineering, and you have to know how all the smelting and refining game, and their enormous forwarding of ships and enormous handling of materials game. And then you have to learn a great deal about not being wasteful in those materials. I'll just give you a very important big lesson and a big economic change that occurred, brought out by Henry Ford. Not only did Henry Ford really get into the first mass production of big things, but he, I don't think I told you, Henry Ford was completely inspired as he's a farm boy, and he wanted to have his farmers able to get to market, to bring things in and bring things home. He wanted to be able to get around a little more effectively. He wanted a vehicle that could really run around on the farm and be very hardy. And that brought him into the fact that he could bring down the prices by mass production for his farmer. So his motivation was not one of making money, never was. And he had great run-ins with the money makers, particularly with J.P. Morgan. Henry Ford, at the time of, incidentally, he developed the Cadillac, and then that people, shareholders, he had people who backed him and so forth, and he got into shareholder style, and he lost his Cadillac, and then he started all of this very much better kind of his pure farm vehicle. And Henry found himself being opposed by this General Motors group that began together and backed by the J.P. Morgan, by the big money. Henry, however, was extraordinarily ingenious in his mass production techniques and making tools and so forth. And when the World War I did get going, and the English were trying so hard to get America to come in and help them, the Germans were trying equally hard to get America to come in, get this enormous production, which was obviously very greatly amplifiable in America. Whichever side it would come in on would really make the difference in this, because the grand strategy was line of supply. And the Americans might really be able to outproduce in ships and in one way or another get the goods there. England without them could not get on, and Germany really without them really couldn't get on. So we have the Henry Ford completely distressed by the idea of that World War I. He said, war is just awful. So by this time, he had learned from his first experience with the Cadillac group, he gradually bought in all the shares of all the people who backed him. And it cost him a lot to do it. And he paid fantastic prices, and some very great fortune in America came from what Henry Ford paid the stockholders to pay. This gave him then real complete control. He did not have to do things in the terms of what money makers or people who are only interested in making profits. He really could make an absolute pure decision about how to really be efficient in production. And came then this big world war, and the English said, so eager to have help. Henry Ford built he bought a very large ship, ocean ship, and painted all over the sides. And he made a peace ship, and he sent it all around the world, hoping he could convince people that we ought to have peace. It was typical to me about all you can do with protesting. He found it just didn't work. And so he said, inasmuch as it doesn't work, I don't like war, but then the thing to do is to get the war over with. So I find I can't stop it. So what I'll do is I'll join up and get it over with. So he told the English he'd like to help them get it over with in a hurry. And he didn't really like the imperialism that he felt in Germany. He felt that the English would be the best one to aid, so he had to aid one of them to get it over with. So he told the English he was going to help them. But he'd already had English factories and assemblies. They were just overwhelmed with the difference it was going to mean to them. So Henry really did help them very, very greatly. Well, I would then point out that at the time of coming into World War I, we just had something called mild steel. And different steel makers made different steels, but they was really not classified. There were no standards operative in industry at all. And steel rusted very badly, and everywhere when I was young, coming into Boston and so forth, everywhere was rust. Outside we see big dumps and things, but it was worse looking dumps here, because everything was rusting, and this brownness was everywhere. It was a very disagreeable sight. And so Henry Ford then was with the English, and the English had the Grand Command in England was approached by one of the English scientists, and he said, wouldn't it be just as good as getting so many guns to the front if we could, or getting twice as many guns to the front, if we could make the guns that do get to the front last twice as long? And they said, please don't bother us. And then they said, what did you say? How could you do such a nonsensical thing? They said, well, we had in the drawers here since 1854, and nobody's been interested in it, and they pulled out alloy steels. Now, what had happened was that the steel makers, really, first steel making came then with what I call the great pirates with you, then found that the wooden sailing ships, which they put the steam engines into, weren't really strong because they could drive them faster than really was good for that wood. And they came into steel ships. And with the building of the steel ships, then they got into very, very powerful capabilities, you know, and then they got into the war buildings and so forth. When it was simply the masters of the water ocean world who then used their resources to build the blast furnaces. The blast furnaces were making steel in America and around the world for 50 years. Yes, 50 years of making steel before a piece of steel went in a ship in the ocean. There was I'm leaving out there the Monitor Merrimack business, which was experimental militarily, but before any of the merchant ships began to be 50 years. And the people then who had started not only producing the steel from the ships, and then they found themselves needing electric generators, and they got themselves into boilers, and there was an enormous amount of manufacture of very special equipment going in that ship. When there was then saturation of the market of ships, then the owners of the blast furnaces and the owners of the General Electrics and so forth found that there were other customers on the land that never thought about it. They found that then municipalities would buy the electric generating equipment, which they only thought was good for battleships or for ships of the sea. So suddenly there were outlets, and this became business in its own right, and they found, in contradistinction to the money they could make of the ships across the ocean bringing cargoes, began to make much more money out of the manufacturing. So steel making then became a very big, U.S. Steel, all of them invested in fantastic operations. Quite a lot of it went on here actually in Philadelphia. And we have, it was a Pennsylvania game, and Pittsburgh very powerfully. We have then the steel, manufacturing steel. Scientists said to the boss, I'll show you how to make steel so it won't rust. He said, you need to have your head examined. The more it rusts, the more we sell. Did you hear what I said? I said, take the papers away from that man. He's crazy, and call the doctor. And all the manufacturers simply, they had now a mechanical cow they could milk for money, and they didn't want any change. Nothing was more anathema in the early days of American manufacture. This went really up to and through World War I. So it was very much of a shock to the English grand strategy when the generals who didn't know about the business money-making side of it were told by the scientists, we have these alloys here for all these years, and they're going to make the very much stronger steels, and they'll last very much longer. So the secret weapon of World War I was alloys. And it was kept very, very quiet, but suddenly the guns were out shooting the Germans, and it became a very, very important matter. Henry Ford, being then privy to this, having gone into the mass production with the English, helping in every way he could in production, became deeply acquainted with alloys. So he came back with, after World War II, over to his own Detroit operation with a completely new way of looking at things in terms of alloys. So whereas you've often heard it said that Henry Ford was a stubborn old man who insisted just making a single little black Model T, and he was just stubborn, was not so. General Motors was immediately appealing to customers by making a little fancier dashboard and more gears and then more instruments, and they were doing things very superficially. Henry Ford was changing his car much more rapidly than they were, but you couldn't see it. It's the beginning of what I talked about, that invisible world. By the time he went from Model T to Model A in 1928, he had 54 different types of steel he was manufacturing to go into his Model T, exactly the right metal for exactly that function for the particular heats and the particular pressures and tolerances that were logical. So now those alloys were as different as rubies and diamonds. So Henry Ford said, I can't possibly afford to buy steel from U.S. Steel. I'm going to have to, because the people who manufacture the steel, the people wouldn't buy ingots, and they weren't buying this liquid steel coming out of the furnace. People needed forms, so they made sheets and plate and so forth, and angle irons and I-beams or whatever it may be, many sections. They got out enough standards to seemingly satisfy most manufacturers. There they had the stuff. So Henry then said, I can't possibly afford to buy sheet, and the only way you could get it from them was buying a sheet in some finished form. I can't buy sheet or I-beams and melt them up and start to make my alloys. So he said, I'm going to have to go into my own mining. So he then, and they found that all the ships belonged to the J.P. Morgan group of the banks. He couldn't use the ships to go to Mesabi. So he set up his own, he built his own ships, and he bought his own iron range at Mesabi, and he had to set up what he called the Toledo and Detroit and Irons and Railroad, and he then started actually manufacturing his own steel and making the right alloys. Now, this became very, very impressive to Henry, and Henry began then his cars. The reason Henry Ford prospered wasn't because a stubborn old man just simply sold sort of a simple product to simpleton people. It's because his alloys did work, and the cars, you could really abuse them. They could really be outdoors there, and they weren't rusting, and the farmer could really use it, and they just didn't get into trouble. So the farmers just was swear about it, and incidentally, at that time, you buy the Ford for $450. It was a very nice price and a beautiful product. And so Henry began then to realize, once he was in alloys, he had then research department going and finding better alloys. He became very much of an evolution in alloys. And this then told him that, now remember, these metals don't come on the farm, and they don't come from the same hills at all. They came from all over the world. So gradually Henry Ford began to have ships coming from all over the world, and he began to have railroad cars coming from all over the world. And Henry then got up a very extraordinary idea. He said, I see then that if I were just dealing in end products, I could afford to keep a warehouse full of this resource I'm going to use and a warehouse full of that. But inasmuch as I'm going to change my design overnight for this alloy, that alloy, if I were to buy any amount of material and have it in a warehouse, then suddenly I've changed my formula, I don't use it. He said, I can't possibly afford to do that. And anything sitting in warehouses, they're simply liable to be absolutely lost capital altogether, and he was having to play very tightly. Incidentally, there was a point where when he got into his mass production tool-up, particularly on this, going in his own iron mines, he got where he needed money, needed very badly, and J.P. Morgan had loaned him money, and he got up to where it was $70 million, which was a very large amount of money in those days, I assure you, and J.P. Morgan was going to foreclose. I told you about the contract where the contract for a distributor required that they take so many cars, and Henry simply forced cars on all his distributors, and they had to get the cash. Therefore, the distributor went to the bank. So the local banks, in fact, the J.P. Morgan banks, had to come up with the money to pay for these cars that the distributors had agreed to take, and he got $70 million, which he was collectible on his contracts. And they did awful publicity about him, this cruel man doing really poor distributors, and he was then he got clear of J.P. Morgan, and the only reason we really had very, very great progress on what I would consider the very pro-human side of technology was that he continually was frustrating the money makers and coming up with a new. Now, he said then, if I can't have my materials in a warehouse, then I'm going to have to get up an entirely new system. I've got to know how fast things are going to get to me. I've got to keep track of things. So he got up a very extraordinary checking system, and I'll tell you about that. As first he had, if you bought a car of limestone, when I was making those fibrous blocks in the Chicago area, I was making them down in Joliet, Illinois, and I made them magnesium oxychloride cement, which came from a grinding mill down in Joliet. So I set up my factory right alongside of them, but this man who owned that, Schindler, sold a great deal to Henry Ford in the way of grind limestone, things that he needed in the steel making. And when Henry Ford bought a car, he would telephone his purchasing, to buy a car, it had to be rolling that day, and there's a Ford checker on with the car, went out with it. He had checkers on all these shipments, and they were continually reporting to where everything was all the time. Henry Ford paid cash for this day, absolute cash that day, and went away that day. You had to give him very fast service. You had to be able to keep track of when he needed things. You must get them in a hurry. You must know sources where he could get things starting in a hurry. So he set up a game, and this is nothing could have been more world, because his operation really did have ships coming with nitrates out of Waikiki. They were all over the world. And what he did then, developed a world strategy, very much like the Chief of Naval Operations of where all our ships are. And had every order of a train, every carload was, and the rate at which they were flowing towards Detroit, or towards his other assembly plants gradually as time went on. And this is the first really time coordination, and he stopped forever having anything in warehouses. He could slow down the car a little, so all his complete inventory was in motion. It was the largest moving picture that's ever been conceived of, the biggest scenario ever conceived of, and to make that really work was, to me, incredible that a little human being could get up a world operation of that size, particularly in the years when he did this. We didn't have the radio wasn't going, the kinds of things you and I would like to have going. Yes, there was a Morse code, that's where you do SOS, so there was a tapping out of that. But there was no voice like that, and we didn't have the telephone lines extended to the house. Much was done by telegraph. Anyway, he set up this, and this brought about incredible change in the world pattern, because it gave you cities, and how cities began to, and how the landowner, the great baron, said, you got to come inside the walls here, and they stored things in there. So when I was young, warehouses were part of the scene. Everywhere was warehouses in big cities. In New York or Boston or Philadelphia, enormous numbers of warehouses. That's full of stuff. And warehouses are gone altogether now. They're only for furniture, things like that. But no corporation, every corporation followed it, realized he'd lost enormous amounts of money through warehousing. He must not do it. So they all took on his time-controlled study. Now, this changed cities very much when he gave up the warehouses. Now, Henry, I want you to realize then how this extraordinary way this man is working, and how it is changing economics, and this is all part of what I would then call design science. And when you play world game, you're playing design science, and you are seeing whether you make a better bearing. You've got to understand your production tools. And this Henry was incredible in the sense of production tools, and he became enamored of interchangeability of parts, which, again, the art had not developed. He said, we get down to fine enough tolerances, we'll be able to have interchangeable parts. This brought him into He fostered there were some Swedish tool gauge makers, very extraordinary gauges, and these men had learned how making very special lathes, how they could control things to 10,000 of an inch to 100,000 of an inch, so forth. So we had gauge blocks and so forth. Henry fostered that whole development of those Swedish men, so he could really then setting up his tools with calibers with incredibly fine dimensions. These are not things that you and I can do with our eye. I don't know whether you've ever tried this out on drafting, but you have in your engineer's scale 50th of an inch usually. There are some with 100th of an inch. But the human eye could not really differentiate. Beyond that, it gets blurred. It gets into gray. So when we get into offset, when you get into printing, you can then have little points in the colored printing, just little tiny little points, and get to Ben-Day screens and so forth, down to 200 and so forth. It looks like absolute, complete, beautiful, continuous color. Or you don't see any of these separate gradations. So that there's a limit to how far the human eye can differentiate intervals. And that's just about 100th of an inch. So when you can get into 10,000th of an inch and 100,000th of an inch, incidentally, in the controls today, I've mentioned it, they've gotten up to 1/10 millionth of an inch in some of the modern airspace technology. Now this makes, as I gave you also, the difference in strength you can get by composite to alignment. So Henry got into saying, you can't have individual borings and things like that. You have to have jig boring. You have to have all the bearings of this machine all in beautiful, absolute rigid alignment, so all the holes are going to line up. You don't do them independently. So he got into incredible developments. And all this he was precedent for all of this. And fast he would do it. General Motors now after copy, but now this is all part again. And I want you to understand. I talk world game. I do not mean then looking at the map and looking at the resources and people and sort of making chess moves at all. My world game is played entirely by design science and what is then called comprehensive anticipatory design science. And comprehensive because you've got to think about the world, you've got to think, everything is involved. It has to do with the atmosphere, exhausting the biosphere. You can't do that, obviously. You've got to think about the side effects, and you've got to be responsible for disturbing the earth, participating in nature's own transforming in every kind of way. You must be a responsible participant in nature's own evolution. And it's just exactly the opposite of the money making. All your control. And I was able to, luckily I committed myself to the precession and assumed that if I did what nature wants to do and trying to do, then I would find myself getting on, and that part did work. But not, if I had ever said I'm going to carry on just money making, I'd really been licked. I'm taking you back now then to other things I've been talking about. I want to get you understand what I meant by world game. I found a great many people very excited when I first disclosed my world gaming, which I've been doing since 1927, because I took my Navy experience of world, because Navy is world inherently, and the Army is a local. And so the Navy had war games, and there was a war college, and the game was the Sunday warriors declare the politician do that. That's not the Navy, but now you got the job of how to get all the world's resources under control, control that line of supply. That's it. Who's going to control the line of supply? That's the one that's going to run the world. So there was a grand strategy, and I was very used to then thinking in resources, and so I made up my mind in 1927. When I started my big game, I was going to peel off. I'm going to take my Navy World War games, and I'm going to play it now on a basis of where are the resources, and how do I use all the technologies and so forth to make man a success, and applying it to the livingery instead of the weaponry, applying to what do we need for environment controls. Now, when I was explaining this for the first group, the Medi Gable was a part of, I went through many scenarios. I went through then various things that I did, and then working assumptions of if you make this design, then what are the side effects and so forth, and then you can get some scoring. And because I was dealing with things I was very familiar with, and many times I ran through and I knew all my answers as I gave them, but because I could give them something immediately really quite convincing how powerful that was. Those who participated, and a number of the individuals who participated in that game were very, very excited in New York, and some of them really rushed off in a hurry because they found it was so dramatic. It was pretty easy to play a game of scenario, and what they did, you get some maps and really reciting and doing what I was doing up there. And this could be very exciting and impressive to people because they could see the results in a hurry. Otherwise, they were really play actors going through some acts that I'd gone through. And this then brought about various other side results because they didn't really know anything about the design science side. So they were simply talking about already tested cases, and not getting at what was really fundamental to me. So I found there was such a misunderstanding the world game began to develop that I asked all the people participating to stop using the word world game and go into what they call world game studies, but please not call it world games, and begin to understand and really feel the design science side. And so everybody who was participating with me was very responsible, and they did just that. Gayos groups, or you call it world game design, you call it world game studies group, scenarios. But they've now gotten so good and are so familiar with this being design science that I think, I felt as I was this last June, the seminar they ran here at Pennsylvania should really, from now on, have no apprehension about they are using the word world game, but I don't want to be lost the significance of this world game capability for humanity, and it really is completely dependent on really feeling the design science side of things. So that when I'm showing you pictures of cars, and it's just fun, I've had a lot of excitement with it, I want you to continually think with me about all the other parts of it, the responsibility. I said, are you going to buy the tools or are you going to rent them, and so forth. As for instance, after Bridgeport, I said, I will never again own another tool. And I will only do things in other people's shops where they have tools, where they need the tools. And I'm not going to hire anybody. I'm only going to go to another man and pay him to take the people he already has hired and his machinery and give him a contract to produce the thing, so that the people will not be afraid of, when they get through with my part, that they're not going to have a job. This really had to be completely disconnected. That is why when it came to doing what we're talking today about the house, the first full-size Dymaxion house, the Beech aircraft, I made just such a deal with them, and I'll tell you how that came about, because it's important for you to also know how these things come about. At all times here, going back to just the 1922, my 5 little factories, I continually learning things that happened. I found I always lost my tools. Tools disappear anyway. People want tools, and they disappear very easily anyway, and you spend an enormous amount trying to guard them. But I saw that I had time and again set up my own shops, got all my tools very expensively, and either they were stolen or I found I couldn't afford to keep them one way or another, I had to let them go. So this brought me to absolutely forced a new strategy as a little individual to carry on. Now, there was an item that I went very close to the other day with you and failed to say something. And as I was talking most recently just about Ford and one thing or another, I began to dawn that I ought to make one little digression over there and bring it in. Do that inventorying, the mobile inventory of Henry Ford. I have something else to think about now. I feel then, thinking about the human individual as a conceiver, as a comprehensive anticipatory design scientist, I've also said to myself, such words as artist and poet are names that cannot be professed by individuals, but society in retrospect can really, but in real retrospect, not right away, can evaluate as to whether that really did have something to do with the evolutionary events of humanity. And my own guess is that Henry Ford, Henry thought of art, the word A-R-T, as something that was in museums or in galleries in some rich men's houses. And he did not like at all the gallery world of New York and that, and he felt that that's part of the money people game and didn't feel right to him at all. His sense of art was, he liked old-fashioned American music, and then Americana in particular, and he went out buying old inns like the Wayside Inn in Massachusetts and brought them out to his Deerfield park out there in Detroit. And one of the things he liked very much was, I said, the fiddlers and so forth, the kind of music that Janet is in. He was very, very great patron of that. But he also was a twinkle dancer, and he literally could jump over his own desk, even at a considerable age. I don't know, it's up to possibly 65 or so, he still jump over his own desk. And because he loved to go out in that kind of music and dancing. But that was art to Henry, and the rest was not. He never thought of what he was doing himself as an art. And as I point out to you, as we go through the ages, there are different canvases and there are different tools of the artist. And to me, in the 20th century, this man was really an artist on behalf of humanity. He was a great conceiver. I felt that time study made of the world, and actually painted the picture where the ships were going, they were carrying it, and he was in touch with them. He was conducting a great orchestra and really making it work. I think this would possibly, in my estimate, Henry Ford will be in the 21st century, 20th century, we call the great artist of the 20th century, the great artist. And it'll be really be very moving. They'll begin to dig up his books and find the things Henry is saying, because he's been very misreported, because big money just did not like Henry. He was very much of a troublemaker for it. And they had great power, that big money, and the propaganda was really, propaganda is very powerful, and particularly in the power structure, and this is the powerful people, and this is the way they say, that's the way I like and so forth. Other people don't really tend to gainsay that. It has to be terribly, terribly powerful. And they own the newspaper, in fact they own this critic, and the critics say this that way. It's not something you can cope with very easily. So Henry will gradually emerge. I'm very sad that his own son, Edsel, did not understand this extraordinary phenomenon, Henry, his father. So Edsel was absolutely corruptible, and the big money brought him in, and so he joined up with the big money makers. When at the time of the 50th anniversary of the Ford Motor Company, young Henry III coming along, I hoped he might understand, and I tried to, incidentally, in my book, Nine Chains to the Moon, I talk about Henry this way. And I gave them a copy of Nine Chains to the Moon. I said, I think you ought to be celebrating Henry here as the artist. The family said, absolutely no nonsense. They did not see it that way at all. They were really seeing it the very, very hard way. Now, with your sensitivity alerted about design science, it's interesting also to keep ourselves right up to the minute. I had a telephone call at the office just before I came over here from Alvin Toffler. I don't know whether you know Alvin Toffler, but he's a very, very extraordinarily good writer. And Alvin said that he had been in Washington during all the formation of the new Congress. And he said that so much went on, all this young blood of the Congress, which we all read about, and they're all challenging the old committees, which are absolutely deadened and made our representative system almost useless and highly corruptible. So that we had that young group then getting at the committees. But he said, what was not reported in the news, he said good news rarely gets reported, but one of the most important things that came out of it was that it became a statutory requirement in the government that all the new committees now all have to have a futures control. They have to be literally looking ahead. And he said this hasn't been published for some reason. This didn't say anything about it. But he said he, Alvin, and a number of other people were so excited by this, he called me up to know whether I would join forces with him, and he's developing a group with the name good comprehensive and anticipatory committee, and they were wanting to congratulate the Congress as people who are really very well known as writers, to have some authority and credit with society, to be congratulating the Congress on this, but he said, well, get them going. I said, you might use the popular term, get cracking, and that would be the thing. So he's going to use that term. At any rate, I said I would join up. But I think it's interesting that we have our Congress getting around to the word being used as anticipatory. How many years I've had comprehensive anticipatory design science, people think, what all this verbosity about here? You're just industrial design or something. Well, I found industrial design, incidentally, is a great misnomer. And industrial design came about, the words were invented in the mid-20s. They were invented when great many people after World War I, not knowing that all that tooling was available, was going to suddenly go in a big direction, didn't know you were going to get an enormous amount of production of automobiles. And that's exactly what happened. As we went into World War I, there were 125 automobile manufacturers, and every one of them started with a racing man, an ingenious inventor, building his own car, and got a name with his Apis and whichever the names were. These are all very competent guys, and they really were interested in making a car, and they were interested and loved driving it and so forth, and they liked the public's interest, and so the show was very fascinating. But somebody come along and said, can you make me one of those cars? And I said, I don't know how much time I've got busy racing it. And so businessmen began to hear this being said, and said, they stood behind these cars and said, man wants to buy one. He said, right, Joe, I'll help you make this car. So they gradually all got making cars. So as we came into World War I, 125 different automobile companies, all primary. And so after World War I, and all this machinery was there, and production started getting really going with the Henry Ford ideas. It really very different. So the little guy didn't have those kind of tools. So the first thing you began to realize, if you're going to produce at all, you had to have tools. And so there were lots of extraordinarily good cars, some superb pieces of design. and tooling those up was quite something. So that automobile company, after automobile came going bust. They bought a lot of tools, and then they got 30,000 orders and 15,000 orders. That looks like a lot of orders, then. They ain't going to make some money out of that. Anyway, people in Wall Street all began betting on automobile companies. Boy, this is a brand new one, and so all America began to bet on it. So a lot of shares are sold in a lot of automobile companies, all going bust. And that got to be a very sour turn of affairs. So there was a complex of them that got sold. Primarily, there was the Dodge Group, and they were in real trouble. So there's a banking firm in New York, Dillon Reed at the time, and they then put together a group of the bankrupt firms, because Dillon Reed had some design science, some engineers really making some studies, and they found that you could have only really one premium car where people would pay anything. It was a very rich man, so it's a Rolls Royce. The Americans couldn't really break through on that one. Rolls had it. And then you might get a sort of competitor to that one, but it'd have to work over hard, so there could be one Cadillac, one Packard, some kind of fancy car out there. Then there was really a good sort of middle price one, like the Buick size, and then there was a production car. They said if you're up against it, if you want to go in that premium one, you're probably going to go bust. It's very, very hard to just. If you want to go in that middle one, that's going to be pretty difficult also, because there's too many fluctuations. But to get to the mass production one, what they learned was, I'm going to give you a diagram. We have what it costs to tool up. And this tooling up is really running into big millions of dollars. So there were the buildings themselves, and all the tools went in and so forth, and had to hire a lot of people producing, big labor force going, and a lot of administrators before we ever produced anything. So there was then this enormous capital cost at the outset. If you then made that capital cost and you only produced one car, you'd have to charge 70 million for that car, 50 million, whatever it is, for the car. And obviously nobody's going to pay you 50 million for the car. So what they found was that the automobile itself, after you've designed it, you freeze your design, and it weighs just so much. And in that automobile, there were very many very heavy cars in those days. But let me just take somewhere 3 tons of automobile. Out of the 3 tons, very large part of that is about 2 tons is steel. And once you get mass purchasing of steel, by the time you buy 100 cars, the price does not go down anymore. So there's really a fixed price for production steel. So therefore you find that the car, as designed, has a base price per pound. So much steel, so much glass, whatever it may be. The early ones didn't have much glass. They were all open toe-rings and so forth. But there was a glass windshield. Even then they had celluloid windshields, those sloping ones, because the glass was an expensive part to put in there. And it weighed a whole lot. Anyway, you had a base price of your car per pound. And you had then the capital cost up here. So obviously, you had then, if you divide the number of cars you produce, you divide that number into your capital cost, and that's the overhead in relation to the fixed cost to the cost per pound. So the overhead is very different then from the fixed cost. Now, they found then, not until in the size of operation of an automobile, not until the record made it very clear, not until you got selling 130,000 cars a year could you go into mass production. So what Dillon Reed did was to mass together, buy enough factories that had gone bust. The tools, when the company went bust, the tools didn't go bust. They're beautiful tools. Lovely build press. So they put enough companies together to get a mass-produced capability of more than 130,000 cars. And they set about then to develop a car that they would sell that way. This became then what the Chrysler Group. And Walter Chrysler, then I talked about him, he was a extremely good actual mechanic. He was really a true production engineering man too. And so that was Dillon Reed. And with it came then, this is mid-20s, big money now. Suddenly said we now really know what we're doing, and setting up this Chrysler company. And Chrysler really was an incredible hit. It was a beautiful design at the time. First car with four-wheel brakes, and first car that had really beautifully lined bearings and so forth. It really was truly superior, fantastic little thing. And now that Wall Street was in the automobile business in a big way and really looking at big things, they said, the thing that really is making trouble is that in Detroit, we have all these inventors who made these cars, and we bring them together, and all those men are interested in inventing and making a better car. What we got to do is make money. And we can't have changes and changes. These people are continually changing things. They're never contented. So they mess up the whole program, everything they looked into, so that we've got to get all the inventors out of Detroit. And so all we want is production men in Detroit. And this is exactly what they did. They're great power. So then everybody said, well, if you're not improving the car, you're not going to be, because American people love the automobile show. Their whole life is something around this new ability to roll from here to there instead of walking from here to there. So it was a very big thing. It was terribly exciting, and our life began to change. I was really able to cover distances never dreamt I could cover. I could have these 5 factories and be getting around. Well, automobile show. So the Dillon Reed then said, that's very good. The advertising houses up in Midtown New York said to her, this is where the big advertising firms began to be known in a powerful way. They said, just in that year, 1926, the airbrush was invented. And you really do some very nice modulation in a hurry with an airbrush. And so they said, the advertising house said, we'll handle that. We really won't change the car. All we want is reliable production and reliable parts. We're going to turn out a good car now and really produce it, really make some money. And we'll take care of the newness factor with the public, so they're going to feel got a new model simply by superficiality. We paint a new picture, we dress the upside of the car. And this is the word industrial designer. So the industrial designer was a stylist, a superficial stylist of machinery, and began to, such words as schmaltz and so forth began to come along. And it was the beginning of America beginning to deceive itself, where the money-making side really began to corrupt it. Really, a tremendous earnestness of the human being to really understand his car. It was a very exciting thing to me to really understand my car and to learn more and more about the gas in the carburetions and electronics. Fascinating. But suddenly they said, we don't want you to do that, and the new banking was said, we don't want you to even have to lift the hood, and so forth. Well, you could make that seem like a great virtue, and so they got to the point where not only if you did lift the hood, then everything's arranged such a way you cannot get at the part unless you have the special tool, that particular service station. All this was deliberately done. Now, anyway, I want you to know where industrial design, so a great many beautiful human beings, like kids go into architecture, get the idea they're going to be designing people's buildings instead of learning how to just be a draftsman in somebody's mechanical office there. And so a number of kids say, industry is really a fascinating thing. I'm going to be industrial. I really understand how you design an industry. They're not taught that way at all. They don't know anything about these tolerances. They simply are then really, at the schools, they are near the engineering department. They learn a little about how it goes, but their job is to make it, to sell it. And furthermore, industrial design is also used as second-story people to go and steal the other man's design and so forth. It is not a nice profession. And if you were to get deeply into it, then as you talked about, architecture really tends to just be sort of a merchandising game where the man is really a salesman and having really taken incredible amounts of orders and doesn't have his own way at all. Because the patron decides he's going to build the building, the architect doesn't decide it. And whether what the patron's going to build that building for is a good idea or not, the architect doesn't question that. Architects don't say to the patron, I don't think you want to build that building. I don't think you'll be making money. They don't say those kinds of things. So the poor architect wants to eat, and his family wants to eat, so he said, thank you, mister, you're going to take me on like that. And the patron said, my wife liked to look like this. I got some pictures here she told me about, so I got to get that in there. And then it turns out that the building code said it's going to be like that, and the labor union said it's going to be like that, and the patron said, I don't want you to make any special doorknobs to get out of Sweet's catalog. So I said, in the end, he just is a good taste purchasing agent. So, because he's using time savers and all the standards and everything, and then much of it's getting on the computer today anyway, so that he's really just a salesman. The architect has to be a salesman for his poor office, try to struggle along this group coming together, very nice human beings, see if they can keep eating. Now, I want you to feel deeply with me. I talk hard this way because I've been in it so much that I really do know what the values are here. And I do see then, when I talked about what the little individual can do, that he's got to understand these things. He just can't possibly survive out there if you don't really understand just what lawyers are doing and what patents are doing. You've got to understand that patent world, and you've got to understand what people are up to in their contracts and trying to make you buy things or whatever it may be. You have to be absolutely, have real discriminatory capability out of experience. And I was thinking, I keep getting very close to something I wanted to talk about to do, possibly the Chrysler, Henry Ford. Something I left out telling you the other day, and it'll come further. Next time I'm going to interrupt myself where I am and let it say it. I'm also always fascinated the way our brains do work, and about this call up and recall and how to accommodate it, because the information, you're suddenly being challenged something new right in the middle of something. And you stop talking to people at the table and write it down. Or it's something to be coped with. And particularly if you really are trying to find out how, through your own sensitivity, how to accommodate what nature's trying to do, because I think we are very much receptors, and as I say, evolution is trying very hard to make man a success, so we all get these little things to think about. And she really means to interrupt, and I've tried to play all kinds of games myself, so I won't forget what she's saying, and yet finish that conversation and get over here. And tonight I've missed one, and I hope it'll come back. I think it will. Oh, all right. I then gave you World War I. Secret weapon was alloys. This became then, with Henry getting into the alloys and accommodating it by not having any storages that imposed any reason why he shouldn't make a change in the design in a hurry. We have then all of industry catching on to that, so as we enter World War II, every one of the, particularly got in the aircraft, but all the great production plants had enormous amounts of alloys, so that in an aircraft plant, you know you're going to need a lot of different new alloys of aluminum and all kinds of aircraft. Every one of these alloys has special capabilities. As we get into really good design, such as of an airplane, we do get into being absolutely specific on the alloy you have to use. You must really know that strength. You're doing everything is strength weight ratios. In the air world, you're getting up there in the sky, the stresses are going to occur. You've got to know just what you're doing. So aircraft plant, incredible bins, these vertical bins of different alloys of every different type of angle iron, every different angle iron of different size, and each one has color-coded and for different kind of alloys and so forth. The plants were incredible forests of these alloys in some usable form as you use an aircraft. In the aircraft, you were not getting into mass production. You were going to then have a special craftsman going to take this piece of metal and put it into his lathe or whatever it is and get it in the next form. We're continually forming, but forming relatively few parts compared to the automobile game. Automobiles have what they call Class A tools. They could stamp out 10 million parts, but in the aircraft industry, we got into, I spoke to you about it, soft tooling, so good for 100 parts, and that's, you're going to change the design pretty soon anyway, so that's enough. I'll be coming to that point and following through on it really very powerfully with you in a minute. But World War II then, here was this forest of alloys. And World War I, you didn't know anything about alloys at all, so that enormous numbers of experts on those alloys. Research was still going on, and so new pieces would come in. As a consequence, the engineers designing parts would then, when you get on the production side, you're going to produce the part, you have a great deal of scrap. Furthermore, the engineers had then been told that as you roll a sheet of aluminum, at the edge of the rollers, there's completely different pressure from the middle of the area. So you must only use the middle of the area. So they were cutting anything you're going to produce. They specified it had to be cut out of the heart of the sheet. The amount of scrap was very great. It got to the point where in car loadings and backlog of cars needed, almost 3 times as many cars were being used to take scrap away from factories as taking fresh material to them. Because when you got in the scrap, it took a lot of room. This got to be an incredibly inefficient new aspect of production at the time of World War II. Now, I'm going to, because the next thing I'm going to show you, which will be the Beech aircraft house that are built in Beech aircraft, is the airplane world. I'd like you to have a strong feeling about things that control the conditions under which I came there. And I did make my deal with them only on the basis of using the very best men they had, best mechanics who were absolutely certain of their jobs. And now, with World War II looming, the automobile companies have gotten very powerful and strong, and that's got to be very, very big business. And we have war looming, and this time I was 1938 to 40. I told you I was technical science editor in Fortune magazine. I was loaned by Fortune in 1940 to write a book on the Chrysler Company. I was loaned to the Chrysler Company to write a book about the Chrysler Company. And one other Fortune editor, Larry, I don't say it, doesn't make a difference. The two of us were loaned to do this job, and it was very much of an experience. Because the Chrysler Company, by this time old Walter had died, and you got a very big business world running it as hard as hard could be. And we were in Detroit, and so they just said the Chrysler Company, in its annual report of its board, chairman of the board of directors, has never done anything more but really just show balance sheets and what the profits and losses are, and told the stockholders nothing. But they said, we're going like to really getting up a propaganda unit. War is coming, and we'd like to have the chairman of the board write a very exhaustive explanation of the Chrysler Company and how powerful that Chrysler Company is, what extraordinary controls it has, and how very suited it is then for enormous amounts of war work. And this is very much a propaganda undertaking. They had spent $1 million, which is not so much money today, but it was quite a lot at that time. They spent $1 million setting up a research department. Research departments in Detroit up to that time, Henry Ford had them and so forth, but the other boys were simply, their research was spying department to find out what Henry is doing or whatever it is. And so they set up a research department. They asked the engineering department at University of Michigan to design a research department for them. So they developed a generalized research department, and they, being a scientific, a very, very powerful university, they were able then to find all kinds of scientific tools that could be used in research, and they built a building with beautiful glass rooms and tiled each one of these separate rooms that you could look through the glass and see this laboratory, and in them they put all these machines testing every incredible number of things, X-ray diffraction machine, whatever it may be. And they had, and you could walk through the aisles of this thing. It was just a showcase, And then there were scientists, obviously, in white coats. And so these scientists in white coats were taken on from the university. So when I was asked then to write this book, incidentally, they bought some really very beautiful research equipment. And so it turned out when I wrote my book, I did really write about the comprehensive undertaking, producing cars and so forth, and got down then to getting tooled up, and then I found they had a term out there in automobile, after you get your tools, they start smashing metal. That's the expression, start smashing metal. Like the farmer used, I'm going to go out hoeing, but you're smashing metal now, you're tooled up. And that is really the general really picture. You get to have such beautiful tools, just smash it and it comes out all right anyway. I wrote my book, and you can get that book, and it was called New Worlds in Engineering. But I've never had anything I took part in, and I've had more a sense of shame about it. Anyway, I wrote as earnestly and honestly as I could about this whole thing. Then their public relations department, and the name of it I will not necessarily give you, but the man who founded it had also been very part of that Dillon Reed business I spoke to you about, of getting the airbrush and industrial design and deceiving the public. And their public relations people sat on top. They had arranged with Ford, with Fortune magazine to loan me. And they sat right on top of Larry and myself very hard. So I got a beautiful photographer, Life photographer, on Life magazine, George Carger, and we did make incredibly good indoor photographs. It's difficult to do in those days. The blackness, the absorption of light inside the big factories was such that you had to have, when he wanted to go, he had a whole carload of Klieg lights brought from California, from Hollywood, to make pictures, and we did really get superb pictures. They've been, years later in Life magazine, they published the whole of that story, because we did get as good picture you could possibly get of really the manufacturing of automobiles, what all the controls are. Now, I wanted to identify the functioning of, they wanted me to do something about this research about it. I was identifying the function of the researcher in relation to all the production there. And in my story then I said that this man, I showed the things he could do and how I explained exactly how the tools, the instruments worked and what kind of information he could get, and I showed that he could really save the Chrysler Company millions of dollars and so forth. I say so. And the public relations said, the red pencil said, you can't possibly say that this man's going to ask for a raise. Can't have any such thing as that. The whole management was absolutely, all the workers and everybody, absolute enemy. They treat him as enemy. And they really detested their workers. And I could not say a worker was doing anything good or out it went. And every time they came to something that I said they didn't like, they would just and then they left a space there, and in the middle of my text it would say, Chrysler also sells diesel marine engines. They keep putting little advertising skits, leaving out my words, not trying to make the sentence get together again, but in would come this nonsense. So, anyway, this really was quite an insight into a great corporation, and within the Chrysler Company, they did not admit there was even a Ford company, let alone that Walter Chrysler might ever know that I had a car that was my friend. Nobody else had ever invented a car except Walter Chrysler, that's all. There's only one invention of the automobile. He invented the automobile, and that's the way it was, as the public relations dictum. I went to out the different executives' houses. They asked me to go out and see them, and they wanted to write up those executives and so forth. And they're out at Grosse Pointe, and they had great big stone houses, very fancy, and as we're driving up, I see a man out there cutting the lawn, and when I rang the bell, there's quite a little wait, and suddenly the man appears at the front door, and he and his wife, they had no servants, but they put on an act as if there were a great many servants around. And so I got into their library. I found all the libraries were just printed backs of books. There were no books behind them. So they simply, literally, were doing the whole idea of the Detroit thing gone that bad. It was a complete sham. Now, being as intimate as I really was with producing cars myself and having had Walter Chrysler, during the days when the big automobile companies wanted to make my car and then discovered they couldn't make it, the banking system would allow them to do it. I did complete that for you all right, didn't I? I did really see a great deal of those automobile companies, and I would guess as science and technology consultant in Fortune magazine, and then my job as head mechanical engineer, board of economics. I think I possibly, for one reason or another, have had to inspect more manufacturing establishments than anybody ever known. I really got to see the evolution and feel the evolution of the tools come along. And incidentally, at the present time, you really can't, because it's got the invisible revolution. You really just see green boxes now. You used to be able to really see and feel what the tool is doing, but you can't anymore. So now, that really gets you into a kind of education that we're getting into, where the man gets to be a physicist or what. He's really doing something very much as a specialist inside that green box, and society is not seeing it. So this is all the more reason why society has to have the kind of insights I'm trying to give you, and that's one reason I feel tremendous responsibility in doing this picture with you, to try to feel this thing, what happened before it went invisible. As I said to you, I realized that once the computer is there, people would not have the advantage I had of actually seeing the figures go round. I wouldn't have made many discoveries I had if I had to do it longhand. Doing it longhand was a tremendously valuable experience. Now, this brings me then to, I did on Fortune magazine in 1940, the same year that I was doing the Sperry Company and doing Chrysler, things like that. I did the story of Glenn Martin Aircraft down in Baltimore, which is no more. And they were producing Sikorsky. I was up at Bridgeport, and I got to know Sikorsky quite well. And when I was producing my car then, he liked my car very much. At that time, all Sikorsky made were amphibious. They were flying boats. And they made the flying boats for Pan American Airways. There was a great deal, almost all the transoceanic, such as it was all in flying boats. You got bigger and bigger boats. And then Sikorsky then was purchased by United Aircraft and the Pratt & Whitney. United Aircraft owned Pratt & Whitney, producing Sikorsky. They were flying boats. It was not until 1944 that Sikorsky demonstrates his helicopter. So that helicopter to Sikorsky is in a sense a very new venture. They were flying boats. But the best of the big flying boats were made by Glenn Martin down in Baltimore. And so there was a great thought World War II is looming, and those boats are going to be terribly important. There was no idea of the kind of advance we were going to have in airplane engines and so forth, where you wouldn't have to worry about these short water hops, and nobody knew we were going to build the kind of airports we built during World War II. So the water was very, very important up to that time. Now, Glenn Martin's, now, we have the Glenn Martin did everything possible to show me during our research work at Glenn Martin plant that it would be absolutely impossible for the automobile companies to ever, like the Detroit kind of production, to ever enter into the production of an airplane. And so he gave us all the arguments why it can't be done. He showed us then the sheet metal worker. And sheet metal workers, by the way, at my Bridgeport plant, when they're producing my car, that was aluminum body. That aluminum body is hammered out of sheet steel, sheet aluminum. It's possible to hammer steel or aluminum sheet and make it into curvature. You start hammering here, and you start stretching it here. It just keeps spreading out a little. These men don't know it, but what happens is that they are pushing atoms around, because the atoms have critical proximity one with the other. You can push them around, and they still hold on to the other atoms. So one of the things that really surprised me, and I really got into working metals, that you can take metal and gather it. You can start with a sheet and make it up into a chunk, or you can spread it out. The atoms can roll around in one another and get stacked up or be thinned out again. Now, in the producing my car in Bridgeport, the great hammerman I had was a Pole. And the Poles were the hammerman. At Bridgeport, things were supported. It was really one of the great mechanics towns of America in the early days. World War I, it was the great ammunition area. And inland we have Springfield guns and things like that, but Bridgeport was an enormous war town. I found Sikorsky used to lend me people at Bridgeport when I needed making my car. I'm using flexible steel cables, and I want to splice them. To really have strength, you have to splice flexible aircraft steel wires together is a really extraordinary art. And again, only a Pole could do that. Somehow or other, the Poles had very special metal work. And my hammerman, all the hammermen were Poles. And this came, confined from the old armor making, came for ages, the making the breastplates and things like that. They were the great experts in the Polish craftsmen. I found that this was a very interesting thing as I began to know my industry and do prototyping work. After the time I built my car in Bridgeport, all those toolmen and metal workers all moved west because they were needed in prototyping research in Detroit a lot, and they went even further into California, went out wherever the airplane companies were. But a certain amount were used in Detroit, and very few were making experimental cars. But my friend Bill Stout, who produced the first tri-motor aluminum airplane for Henry Ford, then built his Scarab car, I told you, after being very excited by my Dymaxion car. And he had at his little plant beautiful sheet metal workers. And I needed to have some sheet metal work done later on, which would come to in my bathroom, because I wanted to then develop prototypes in copper sheet. And copper sheet is particularly good because steel will get harder and harder, and it's more difficult to anneal. Copper, you can anneal it, you keep working it, just a little bit of heat, and it goes absolutely practically into jelly form, and you can, it just never gets tired. Many of the other metals get tired, and they build up a fatigue, and after you work them enough, they're going to just crack apart. But copper would not do it, so it's particularly good metal for doing prototyping work. We want to get something shaped out, and maybe we're going to produce it in plastic, but we want to remain shaping copper's idea. So I did develop my first mass production bathroom in copper sheet, but I had to go to Detroit for sheet metal work for Hammerman, whereas they were available in Bridgeport, Connecticut in the 30s. By the time I got to that early 30s, late 30s, it all moved west. Now, I spoke Glenn Martin, and Glenn Martin showing me then that the sheet metal worker understood then that the same piece of metal can have twice the tensile strength this way that it has that way, at 90 degrees precessionally. I said the sheet metal workers know that, but nobody else knows it. So if the Detroit people start manufacturing, going to throw metal in, smashing metal, they're put in the wrong way, and the plane's going to come apart. So for every single objection Glenn Martin could get up, Fortune also sort of really just caring about the tycoons and the money makers and so forth, they got some scientists to look at the things that Martin said, and they said, well, the scientist said, well, I've got X-ray diffraction now. I can look at that metal and tell you exactly where the grain is. And we can have then a tool such as was developed in the making the razor blades. The Gillette company found they could take sheet, continuous strip metal, and they could keep running it through, sharpening at both edges, so it's a continuous thing, and then chop it into separate pieces. As they chopped it into separate pieces, they needed to do some more honing and things like that, so that they then developed the mass production of little pneumatic cups, little tiny tubes that just suck, so pick this thing out of the machine and so forth. So they showed that they could take a machine that would pick up the piece of metal and X-ray it, diffract it, know exactly right, and orient it and put it right in the machine the right way. There was not a single thing that Glenn Martin and his engineers could say to me that with the reasons that Detroit could never get into mass production of airplanes, that they couldn't find a scientist who give them some trick that could be played that make it possible. So one reason now the automobile world was able then to convince the American Congress and all their representatives there that that Detroit was ideal to produce airplanes. And say the Glenn Martins and all these people just shaking their heads. It never could be done, they thought. So we have Air Force then was forced by the Congress and by the propaganda of Detroit into agreeing that they were going then to have Detroit produce their airplanes. So Detroit said that, all right, Air Force, you got to have some bombers and fighters, we all know that. And so we want you to design the most modern fighter, absolutely go way out, and the most modern bomber and so forth. And then we're going to tool it up. Now, one of the things I learned in Detroit, in doing the Chrysler Company story, was really a very astonishing and important matter. When they then do go through all this enormous getting ready of a car, where the checks and balances of the people that do have to be satisfied, I say whether it's the sales departments or the banks, and so many people involved, finally get to where you're going to say, this way the car is going to be. So there has to be absolute cutoff, and now we're going to really tool, and then the tooling is very, very expensive. So after tooling up, incidentally, Detroit allows 3 years after the design is finished before you produce, so that their cars are always way behind the times by the time they come out. Because the evolution is much more rapid than that today. Anyway, they had, if a car comes out and something begins to go wrong, people find something wrong in it. They say so then to the distributor. They did everything could to get the distributor some kind of way he could modify, make the thing all right. But if they found that really couldn't be done, they really then had to change the production. The Chrysler Company and all the other automobile companies had a set of Scarlet stationery. And we want to see that Scarlet stationery. Get out of Scarlet. They then call it change order. A change order, and they ring bells everywhere, and they fire 10,000 people, literally. It is an explosion in the automobile game, a change order. As I say, everything's done on the Scarlet stationery, and so everybody just fears this thing. Is one of the things to read them. There must absolutely fear any change. It must be so thorough before it's done. So, having learned that about that, because in the end they don't want any overtime. You know, overtime costs much too much money. So, it's going to take 3 years to tool up, because you must never have 1 second of overtime, and you do nothing really looking out for labor. So, when I then began to combine my experience in what I knew about Chrysler and so forth, my own automobile development, and getting into the aircraft plants and so forth and their production needs, I can then tell you a set of events that took place that were very, very important. America then didn't come in the war right away, but by the time they came in, the English and the Germans had been battling for several years, and everything was who has air control, which is the bombing control, because you're going to get back, if you can bomb all the production capabilities of the side. So this air supremacy was the very essence. And the English and the Germans fighting each other saw that if you change the design a little bit like this, then you can get a little better. So the experience was lethal, but also taught them how to design. So both in Germany and England, design began to really change in a hurry. And they had to develop really new tools. One of the things that happened with Germany and England both realized that you better deploy your factories. I'm telling you more or less a side thing here, but I'll come back to Germans and English deploying factories. But one of the things I learned in the Board of Economic Welfare, because I studied photographs and report after report on the bombings in great industrial manufacturing plants. The walls were an absolute mess, just ruined them, and they tumbled down all over everything. It got cleaned up, and the machinery is usually really very good shape. Now, the machinery is not so destructible, but what somebody hurt was the building, so they cleaned the rubbish away and moved the machinery and put it out in barns. And then they deployed all their operation. So you got the farming family to work at night with the lights all obscured in their building, out in the barn, running the punch press. And they had trucks then go around, pick up this and pick up that, and then assembly plants. Well, you could move your assembly plant pretty around. It had an assembly line under any kind of a barn or some big building. Then you move that around so the enemy really would know where you were, where you're producing it. Deployment by subcontracting became absolutely fundamental in production, particularly that airplane game. Now, but the big thing was the invention by the Germans and the English of tools that you could make quick changes. How they kept inventing ways to change your design rather than produce it exactly the way it had been. Because said to you, in the great fundamentals of economics, that had been that steelmaker said, more it rusts, the more I like. We don't change. I'll tell you, in the great corporations of the world up to the time of World War II, any executive said we'd like to make a change here, we got fired. The only company where you could do it was Henry Ford, and he's the one who made the changes. And he loved it, and somebody really could give him a good idea. He really went after it. But the other companies, no, because you want to make money. You don't want to be spending all your money on these changes. So this was anathema in the idea of making money, but essential if you're going to really get somewhere, that there would be change. So this freeze up of the Chrysler Company and all the other companies, that change order being anathema, was typical really of a sort of a death point of keep a service to humanity. Now, so I said it brought about all kinds of changes, the deployment of the manufacturing, and they then began to develop most extraordinary trucks, because you're going to have a section of a wing, and this wing could get so readily hurt. And so then the trucks they would jig shipping. You didn't have to put the beautiful wing piece in a heavy crate. All shipping up this time had been continually. There's a great shipping art. Anybody produced any machinery had to learn how to put it together, and so it's not going to get hurt while it's being shipped. But suddenly then the trucks themselves. This truck did nothing but carry that airplane wing. It was a beautiful jig shipping. Things came in and took care of the loads in exactly the way you could tell the bumpiest roads. No, put that thing in any jeopardy at all. So jig shipping is called. Now, there are toolings I speak about, and I'm going to get into sort of evolution of things that go on here that are very, very important, which I think you'll find very exciting. The Congress had been persuaded by the same kind of nonsense as that book that I had to write for Chrysler, and they used enormous propaganda. I think they got 125,000 copies that were distributed right away, and this got then the Congress to make the Air Force give the orders to Detroit. And I said Detroit had gotten then, the Air Force had to get out of this design of the bomber, this kind of a fighter. So they tooled up for it. And the kind of planes then that the United States was making to go to Europe, to go for our armed forces, so with them training our armed forces, so forth, they're going to have to fly these things in Europe. So much of being learned by the Germans and the English, and the evolution of the plane was so very rapid that these planes that are being made in the United States became absolutely obsolete. So they developed in America, Detroit said, we take care of that, and we just have a modification line. So they built a second production line. The minute that plane was finished, put up the head of the production line, went right down and got all rebuilt again. Then by the time they got to England, they still were out of date. So in England, they set up a new production, the remodification plant again. And then by the time they literally got into the war, when the Americans then came and did their first bombing strikes and so forth, so many planes were lost. It's absolutely lethal to fly the damn things. And so the Detroit said, that's all right, we're just going to, we absolutely outproduce those people anyway. So the planes are going to get lost, but we just outproduce them. Well, at this point, American mothers began to get to the American congressmen and said, we can't outproduce the kids. And there was the Congress really then suddenly became really alarmed at the rate of the killings, and if it went really any distance, there's going to be incredible slaughter. So they simply said that Air Force, well, what should we do? We've been forcing you all the time. So Air Force said, we're found that the contracts had been made, the lawyers, people had worked to get all these contracts for Detroit. There were so many contracts that so absolutely unbreakable, and all the lawyers by this time were busy on other kinds of war problems. Nobody could undo them, so they just simply let Detroit keep manufacturing this junk, and about a quarter of the Air Force it was sent just to fly them out the Kansas fields and let them stand there, get rid of them, get them out of the way. So what the Air Force said, we'll move west of the Mississippi. All this is east of the Mississippi. They meant move west of the Mississippi, and they went to where the airplane will have been anyway, where it had been moving to. So there was Oklahoma, and particularly Wichita, Kansas. And Wichita, Kansas had 14 aircraft plants and had them there for a very long time. They had 14 airfields. And there were well-known names like Beech and Cessna and so forth, but Boeing number 2 was there and so forth. So Boeing number 2 got the contract for the new B-29, which really had to have you had to forget everything and get something new and get it out in a hurry. During the design and building of the B-29, the first 100 B-29s that were flown, engineers, scientists, everybody working on them, 1 million change orders were written between number 1 and number 100. 1 million change orders. This is quite a change in industry, and get kicked a million change orders. You get one going to fire everybody. This is a very abrupt thing. So that and everything that we had inherited is the British finally able to get America to come in. We're able to have an enormous amount of information on the information, what the intelligence information, what the tools were that the Germans were using, and what the English were able to tell us themselves. So that what we did was, at that point, industry was designed to accommodate change. This is a fantastically important point economically. I know American society doesn't know it, world society. You have to really be in there and that kind of a game to realize, and be as old as I was, to see complete change. Now I saw that change starting, and all these things I'm talking about are design science. I saw the design, this changing when I came into Phelps Dodge as assistant director of the research department after finishing doing my cars. After I finished doing the cars in Bridgeport, I then wrote 9 Chains to the Moon. I was still writing 9 Chains to the Moon when I went into the Phelps Dodge assistant director of research. I mentioned to you that in World War I was the first World War because of dealing in these metals rather than in the vegetation. It was a very different world, and this was then to do with that alloys and particularly then inanimate energy, waterfalls and so forth, and the ability to generate power and bring it from here to there by copper. I've mentioned several times then now that in one year, 1917, we produced, mined and refined and put to work more copper in 1 year than it cumulatively had been produced by all humanity in the whole history of man before. Now, that copper then, being produced this way, was very highly feasible due to 2 inventions that had occurred just before World War I. One was flotation, and the other is electrolytic refining of copper. Flotation made it possible to very quickly refine, and the refining then by electrolysis and depositing the pure copper over here, very great, but you had to have lots of energy for it, obviously. But these reduced the cost of copper production incredibly. To such an extent, it happens that copper and gold and silver tend to co-occur. And you don't, sometimes in the early times, you know whether you had a copper mine or a gold mine or a silver mine. But the amount of copper and silver is very much less plentiful than is the amount of the gold and silver. But it's usually there. So the copper companies are also in the gold and silver business. And so Phelps Dodge had a very important gold business, and they found at the time of World War I, as they then found the cost of the production had been so lowered by electrolytic and refining and by flotation that what the Phelps Dodge and the other big copper companies were getting for gold as they sold it to the government for mints, the cost of the price of the gold paid for the complete mining and refining of copper. So they wouldn't take it out of the ground unless they're going to get a lot of money for it. It was absolutely free to take it out and refine and sell it. Boy, this is a great one to find. That relatively small amount. So he kept taking the gold out to have your confidence there, but take the copper out when you're going to make money. In war times when you make money. So when the war did come on, they didn't really want to take it out, and they could, I said, because they had these new production capabilities. But the copper companies, like everybody else, had also then made a few types of parts. That is wire, pipe, and so forth, and they sold they sold it to fabricators. So that the big sales of copper in America also involved the people who fabricated into the real use forms of society. Copper companies like really just sell wire bar, and they bought the wire bar and made the wire out of it, and so forth. So that they, in order to step up their production, so they could keep up with the incredible sales that the government then gave them, the enormous demand to run that kind of war, the copper companies found that they couldn't meet the demand so they bought in all the customers who, as all the sheet and all the metal workers of wire bar, Habershaw Wire, many very famous names. They were all bought up by the main copper companies. Became branches of the big copper companies, so they could control the production tools and get the stuff out. With this then, in order to make such a big deal in such a hurry, they had to make a good deal for the president of the fabricator who they're buying up. So they said, we're going to keep you on, you'll be an officer of the company, big salary, and it's fine. Okay. So you'll just be in the sales department. Well, we had, I've given you then, also up to the great crash, which I've talked to you about, and then the laying down of the hands of the banks, finding they'd just simply been loaning people's deposits, it wasn't their money at all. Also then finding great power of J.P. Morgan, and J.P. Morgan had, and everything that's really big in America, all the prime contractors of every kind, whether it's General Motors or U.S. Steel, they had 2 or 3 members on the board, and they were absolutely able to control all those companies. They ran the whole thing as one great big show. This was very much interrupted by SEC, and so the banking monies could not go into it. Instead, all kinds of those divisions were made. But then it meant then that at the time I came into Phelps Dodge, this is 1936, and it's 3 years after the New Deal is going, and things are now in a different kind of a stage over here. And so I found that the Phelps Dodge copper products, which then represented all the amalgamation of the manufacturers who they brought in, they ran it separately from the mining company, Phelps Dodge Mining and Phelps Dodge Copper Products. And the salesmen, managers of that company were now, the Depression, one of the big things is to sell copper. So the salesman found it was his market. And the president of the company was a mining man, a mining engineer, very fine man, incidentally. And Louis Casey, he's the one who had the research department take me on to make studies, make forward studies of the industrialization of the world to see the part that copper would be playing in the future years, because they decided I had that kind of capability. And we have then, what I began to see some very fascinating things, because I went really plunged into the history of copper, went back to every monograph, the Bureau of Mines, anything I could find out, whole history of copper, found that historically how there had been a time when Spain was the greatest copper mine, I think, so forth, and paid a great deal, the fastings in their ships or whatever it might be, and how all the copper that had been produced by man, it was expensive, it was used functionally because it was plentiful enough to be used functionally, but the minute they could get a substitute for it, they always put it in because something could cost less. So they began to learn how to get steel that is, let's say, use any kind of steel faster, where you find some way, keep it from rusting, then you have to take the place of the copper. So I found that copper had been in ships, the early great big rib ships that were able to really go around the world. Copper played a very big part. And as fast as they could get less expensive metals put in, they would continually took out the copper. Copper was used because it could also melt up on a annealing condition I spoke to you about. It had all kinds of uses, and countries that were going to go to war always found a need copper. And one of the great tricks historically of copper was to put copper into bronze great statues of the heroes and the kings. This was the way in which a country could start importing copper without really realizing they were just putting up statues of famous people. So it was part of the great war strategy game to have lots of statues where it could be melted up when the war came. Now, what I found was in Phelps-Dodge that the sales department were beginning to annoying the mining group, and they sort of take things over because they needed to make sales, and sales were being very difficult because something was happening that bothered everybody. It had never been in the copper industry before. There was scrap copper around. Obviously, with the enormous production in World War I, you should expect some scrap around, but it had always been assumed that scrap was something that you just had for a little while, and then you used it up. That's the end of that. There was very much the attitude there was in the Club of Rome report, the Meadows report on the limits of growth and so forth a couple of years ago, where I found the economists who did that report were not metallurgists. They didn't know anything about the mining world or production engineering, and they were assuming that the metals or something gets consumed just like strawberries. And if you take it out of the mines, that's all there is now. It's disappeared. They looked at things in that kind of way. I found that wasn't what went on at all. These metals do get melted out and recirculated, melted out and recirculated. So even the time that I was in there, I suddenly found that 84% of all the copper in the world that had ever been mined was still in use. We knew where it was, and been melted out time and again for this use and put into another. And it had drifted from making possible the marine building first, drifted out there, and then got into railroading. Because there was a lot of things you didn't want things to rust. They're very dangerous. Coupling of those cars, a great deal was done in brass. And then as fast as they could afford to, they substituted steel, and the copper was melted out of there. And then it came into this extraordinary new telephone game and electronics in a very big way. And so it was majoring in the electrical world. Anyway, condition, I said, it was scrap was beginning to bother and so the people who'd owned mines were only going to take copper out of the mines when they could make money out of it, found people were selling scrap out there instead. So they didn't monopolize the copper market at all. So the monopoly was broken, and this was a great concern to them. So everybody's worried about scrap, I found, and nobody seemed to know what to say about it. So I made some studies for them. And I really went exhaustively into what I'm saying, because what I did then, because I am a mechanic, I really got into the different classes of manufacture, different classes of goods altogether. And I found, and incidentally, the metals records, I assure you, are very extraordinary. There's so much money is involved that the numbers of agencies that are reporting accurately on metals down in Wall Street are incredible. And so there are a number of associations, and so whether it's Iron and Steel Institute, whatever it may be, superb reporting. So I got into all that, all right, and I was able then to get into something I speak about as lags. There is then a lag gestation rate. You're familiar with that then in human beings. There's no instant baby. So it's 9 months of human beings to make a baby. I found that in the electronics world there was approximately a 2-year lag between invention and use, that in the airplane world there's a 5-year lag. The electronics run was only 2 years because it was subvisible and it was only carried on. You could find out it was better mathematically, and the mathematics you didn't doubt it, or you put it in the better way. It's one of those. That's again the way things move in that invisible world. So we have in the airplane, you need it very bad because they're very dangerous art, but you don't put it in until you're really sure it works. So there's a 5-year lag. I found there's a 10-year lag in automobile between a good invention and it's being used by industry. Turned out to be a 15-year lag in railroading. Turned out to be a 25-year lag in relation to big buildings in the city, and about a 45 to 50-year lag in a single-family dwelling. To give you a little idea, in the building industry, the very slowness, the part of the development of production steel was then you had to have a lot of blast furnaces, you had all kinds of ceramics. And Portland cement, production of Portland cement became a byproduct of producing steel to using some of the byproducts. So that we have the Atlas, Portland Cement, these things standing, they're all alongside the steel companies. It was an amazing thing. It was 50 years, 45 years, 45 years between the steel company making Portland Cement and somebody, a piece of steel dropping in the cement using reinforced concrete. That's the typical of how long you can avoid the obvious in an art. This is the building world. Everybody knew all the building causes, just compression and all the things. And nobody understood that, how that reinforcing worked in those days. The Harvard Stadium is the first big building built with reinforced concrete. It's a very new art. It didn't come into small buildings and dwellings till I brought it in with that stockade system I told you about in the 1922 when I was introducing reinforced concrete columns or so in the small buildings. This was not in there at all. Now, I just want to understand lags. I took the different lags of the different basic manufacturings of the world. Then I went into the records to find out how much copper is really in the building industry. Enormous amounts used to be in it, and there still are. If you look at it in the old buildings, you see those green roofs on these big buildings around it. That's bronze roofing. Because they build it, while you're building it, they build it right, and this is not going to rust. So there's enormous amounts of bronze, and the well-built building had brass and copper plumbing and so forth. So I got into exactly how much of these copper was in buildings, how much copper was in automobiles. At that time, 30 pounds per automobile. They were so expensive, they kept down every ounce of it they could. And so I had all the copper in all the different arts, and how much was out on the ships and so forth. By doing that and taking this lag, I was able then to find out where copper really is on inventory and how long it's going to be before it came out. So what I did was to consolidate all of those, integrated the total inventory of all copper and different lags which are going to come out, found the average would be the largest tonnage would come out every 22 years, 22 and a half years. So with that key, I then began looking at the amount of scrap that was beginning to show up in the 30s, which was really a very new thing on that, which nobody knew how to explain. But I found also in keeping a track of production of copper, they keep very carefully, scrap is a very secondary metal, very carefully sharpened away from newly mined, you know, just what you have. I found then the newly mined copper of 22 and a half years ago, it was exactly the height of my scrap. And there were enough of those to say, it looks like it's really so. I was then, this is 1936 in Phelps Dodge, and I said to Phelps Dodge, I'm quite certain I have a finding here, and World War I was 1917, that we have on the chart of copper production, historically, nothing like this, a cliff went up like that. So I'm going to add 22 and a half years to 1917, I get July 1939. So I said in 1936, in July 39, you're going to be all whelmed with scrap. By that time, I left Phelps Dodge in 38 and went to Fortune. So I was on July 39. The director of research of Phelps Dodge called me up in July and said, Bucky, you're absolutely on, it's happened. And at that time, if you went in New York, or even in Philadelphia here, where there are docks, and docks where shipping was very much more of a matter than it is today. The docks of New York, great docks, there were ships, but enormous, they're filled with lighters that are going to load the ships. And all these great enormous wooden lighters and steel lighters were just piled high with scrap. Every dock in New York was lighters full of scrap. Because not only does copper do this, but steel follows the pattern of copper. So copper is a bellwether, they say. You find out where the copper is going to go, and the steel go that way. So the steel scrappers are there in equal quantities. America was just being overwhelmed with scrap metal. And the reason they were down there at the docks was that they saw World War II was looming. And then the metals industry makes enormous money when the war's on. So they wanted to get the scrap out of the way, and America, then the metals company in America sold all the scrap to Germany and Japan to develop their armaments, which they fired back at. It's a fairly immoral thing to do, but that's exactly what was going on there. But as a kind of it getting out of the country, it did not even get into the economic arguments of World War II. Does not really begin to show up. Just now I'm finding that what I found back in the 30s, and we confirmed absolutely, was something just beginning people realize with all the discussion about ecology and recirculation. This is something I learned way back there. So let me tell you that the 15% of copper that is, or the 16% that we don't know where it is, rather that is not in continuous circulation, we know just where it is. We know where the munition ships are in, and that'll be brought up in due course, and that'll be put to work. In due course, with these metals going, and now the metal, every time the metal comes around every 22 years, the interim know-how is so great. You melt it up, and you load it up with know-how, and melt it up, load it up much more know-how. So every time it comes around, you have much higher performance, the same amount of pounds. You don't have to get into this very, very deeply to realize when I begin to talk about capabilities of taking care of everybody, they're predicated on my knowledge of the rates which these metals are coming around. So that I say, now I'll go back to Phelps Dodge and my giving them this thing about scrap. They didn't know I was going to be right or wrong at the time as I gave it to them. But the thing that was exciting was that the sales department realized that there were no longer the J.P. Morgan directors on the board. Management in general in America was freed by the SEC and the government coming in and purging the banks out of them. The management itself said, you know, we were always appointed by J.P. Morgan. J.P. Morgan controlled the board of directors. The board of directors elected the officers. But the officers of the company said, there's nobody here to say about this. J.P. Morgan's not there, nobody bothering us. So they had to become self-perpetuating. This is a complete new change in America. It became a new, the finance capitalism died, but there was a new kind of capitalism, really management capitalism. And I find this is not particularly well known. These are things that are very important to understand from a design science viewpoint. So next thing about the management capitalism, they said, we don't care where that, these men were handling the sales, they had their own machinery. They were the manufacturers of copper products. They said, we don't care whether it's scrap or not, it's pure copper. And a lot of people think that scrap means it's not pure copper. It's just absolutely pure copper. There's nothing wrong with it at all. It just associates as a pure element. And so they said, we don't care whether it's coming out of scrap. What we make our money by every time the wheels go around and we make a product, we're turning out pipe and wire, we want the wheels to go around. And so they said, the more inventions that come along, the more changes, the more our wheels go around. This new management capitalism realized that change was desirable. And I'll show you since World War II, with the two things I gave you about that the whole thing was organized to accommodate change, and the new management making its money out of change. Suddenly, the new management came out of business school, so we went into corporation. If you couldn't get a change in pretty soon, you're not going to be any vice president, I assure you. So I saw an absolute change in the whole world where the money-making itself began to vote for change. Now, this turns out to be healthier than they know, because again, I find everybody's so specialized. Corporations don't realize the big patterns I'm giving you. They don't realize that we're going to have more and more of that metal to get to the point where we don't have to do any more mining. I assure you. In fact, we've already mined so much. There are some metals we're learning to use, like boron. We didn't know what high tensile strength in there. So there are few scarce metals like that. But by and large, as somebody say to you, the iron and the copper and aluminum, we're practically at a point where we don't have to do any more mining. Because every time it's coming around, we get so much higher performance. We're going to be able to take care of all of humanity and all the children to come and very, very high standards. Okay. I hope you feel also all the time here with me a sense of a personal responsibility and the experience of being allowed to get to such information. I've been incredibly lucky through the years. In the Navy, and the boys that I went to school with and so forth, knowing the Morgans and knowing very, very powerful people. And I don't like, I don't never be treacherous to friends or well, I can't talk this kind of way really. This is really such past history that doesn't make the slightest bit of difference. But I really did. No, I was taken down by the president of the bank, the old New York Trust Company, to meet the officers of J.P. Morgan as a kid when I was doing very well in armament companies. So I saw this bright young man, So I really do know pretty well the decisions do get to be made, and I've been in where I was, as a young man, a young salesman, being pushed to go over here and do this and that, and seeing how things really work. So it's time for a break. We're at 8:30, and I've talked a little longer than usual. We've run 2 hours now, and I'm going to come back, and we're going to get into. You're going to look at things going on in Beech aircraft, and I'm sure your eyes, if you haven't heard what I've been talking about, will be different. I'm sure that as we talk this kind of way, you can't look at things as you did yesterday before. You can really see things and feel them in new ways. Thank you. I'm going to recite you a little very short verse, and best we know it's written by a little old lady in England about a couple of 100 years ago. If all the good people were clever, all clever people were good, the world would be nicer than ever we thought it possibly could. But somehow, 'tis seldom and never that the two hit it off as they should, for the good is so harsh to the clever, and the clever so rude to the good. I'm just saying that because I think the real life saw somewhere between these two. My grandson was about 3, and he was driving with me on the freeway in Los Angeles. We're going along 65 that you're going there, and he was standing in the front of the car with me. I'm driving, and he was sort of fooling around with the instruments. And I was afraid he'd do something might make things go wrong while that speed is not a very good time to be fooling around. So I've been suggesting that he not do that, and he kept at it. So I said, Jamie, you want to be a naughty boy? He said, no. I said, you want to be a good boy? He said, no. So I think that's the way I've felt in my whole life, really. And somebody asked me in the interview how I had so lucky to get such good jobs in my life, and I think I went with these really not jobs in the sense that when I was unfortunate because the managing editor wanted me to come there. He wanted to have somebody try to make clear to the fortune tycoon readers some of the emphasize the scientific background, that they were sort of getting too boastful about how clever they were at making money. He wanted me to do something about that. Russell was a poet himself, and a very beautiful man. Russell Davenport was his name. So he wanted me to come on to Fortune. And Henry Luce liked the idea. I'd known Henry for a long time, and anyway, we tried it out. But I went there for a purpose. It wasn't, in a sense, a job. So the things that I've had to do, I certainly absolutely convinced there's nothing that you can be asked to do that isn't interesting. Although I don't really have inferior jobs and so forth, I find life is just fascinating from any viewpoint. So whether you're the plumber's helper, whether you're learning how you wipe a joint and things, it's just great. Now, but also there's a wonderful fun in life, and there is that human beings are human beings, and they are the temptations and so forth. The human thing is very much in that somewhere between the good and the clever, but it isn't either. not my kind of life. I'm going to go on now, having talked a whole lot about these metals and the design science requirements of understanding some big patterns, and to tell you a little more about it, that immediately at the end of World War I, and the big aircraft companies didn't know, as I said to you the other day, that they're going to have jets to produce. They were looking around for things they could do, and I told you about a meeting with the people made the general panel, but I also, the house that we developed in Beech Aircraft became very interesting to a number of the other bigger aircraft companies, and young Donald Douglas, who was the producer of the famous DC-3 and other DCs before they amalgamated with McDonnell aircraft. I had a wonderful talk with Donald Douglas at the end of World War I. They were interested in the possibility that Douglas Aircraft might produce the Wichita House, which I'm going to show you in a few minutes, which had been produced at Beech Aircraft. Donald Douglas then told me, in relation to the things I've said to you about all those metals that were in great waste in the aircraft industry, enormous amounts of materials that had to be either sent back or somehow or other sold, that in the aircraft industry, I want you to understand, there are really two very different kinds of engineers. There are design engineers. And design engineers then do design the airplane to start off with. And the design engineers do structural analysis, and they know just exactly the right, what strength this part has to have. All that's beautifully done. When the design engineering was over at the time of World War II, then they're going to have to get into production. And they had what was called then production engineering. And production engineering then began to look over the parts that had been designed by the design engineers and figure out how you're going to make those parts. And they found out time and again that the designer of the part really had no knowledge at all of tools. Didn't really know, just only knew the center of that metal was strong, the edges, things like that. He followed those kind of rules. But the production engineer deeply familiar all the fundamentals of production. How many kinds of tools are there? And he could see, because the production engineers are always graduated from being design engineers, so they understand how the design was made by the design engineer, all right, but they really realize then the production of it, that part could be changed. And you could still do exactly what it's designed to do, but it could be designed a little differently to do the same function. Then it could be easy to manufacture this kind of tool, that kind of tool. And so Don Douglas said, I'm never going to have any design engineers ever again who are not already production engineers. I think it's absolutely incredibly stupid to have to do what we did during the war of having all that waste materials being set.